The last time there was a total solar eclipse in the UK skies was on the 11th of August 1999. Anyone within the path of totality saw one of nature's most awe-inspiring sights, as the moon passed in front of the sun and blocked out its light from the earth. I was there in Cornwall, the best place to see it, and for a few minutes we were plunged into total darkness during daylight hours, and the temperature dropped. It was exciting and strange, and made us onlookers reflect on the power of the sun and the vastness of space. Total eclipses don't happen very frequently in the UK. The next one will be on Saturday the 23rd of September 2090, just before 5 p.m. It's quite astounding that mathematicians and astronomers can calculate to the nearest minute when the worldwide eclipses will occur for centuries to come. This is because they understand how three objects can line up and how to calculate when they'll be in a straight line. For this, they use collinearity. Let's find out more. This is Thinkful. You can be asked to show that points are collinear in 2 or 3 dimensions in this course. Whether working in 2 or 3 dimensions, you need to show that A, B, and C are in a straight line like in this diagram. To do this, we'll need to show that the lines joining A to B and B to C are parallel, and then because they both have a common point, they will have to be collinear. If only one of these is true, then the points will not be collinear. For example, if they're parallel but do not share a common point, then they look like this and are not collinear. If they have a common point but they're not parallel, then we have this situation, and again they're not collinear. Here is an example in 2 dimensions. Show that the points A with coordinates -1, 7, B with 5, 4, and C with coordinates 7, 3 are collinear. First, we need to show that the line segments joining A to B and B to C are parallel. We calculate their gradients, and both are -1/2 as shown here. Now we can make 2 statements. One about the gradient being equal, which proves that they're parallel, and one about the common point joining them, therefore proving collinearity. Together they prove that the 3 points must be in a straight line, and we need both statements. Let's look at an example in 3 dimensions, like your eye, the moon, and the sun would be in the total solar eclipse. This question gives us 3 coordinates, A, B, and C, and we're going to prove that the points are collinear. We can write the coordinates as column vectors A, B, and C as shown. Firstly, we form 2 position vectors, A to B and B to C. AB is equal to vector B minus vector A, giving us 3, -6, 3. BC is equal to vector C minus vector B, giving us 4, -8, 4. Vectors have a property that if one is the multiple of the other, or if they're both multiples of the same vector, then they're parallel. Both these vectors are multiples of 1, -2, 1, so they're parallel to that vector and therefore parallel to each other. All we need to do now is make the 2 statements that prove collinearity. As AB and BC are both multiples of 1, -2, 1, they're parallel vectors, and as B is a common point to both, the coordinates A, B, and C are collinear. You might only get to see an annular or partial eclipse in your lifetime. Or maybe you'll be fortunate enough to live long enough and be in the UK in 2090, or somewhere else in the world, experiencing a total eclipse before then. Meanwhile, remember the mathematics of collinearity and the statements you need to make to prove it. You never know, by 2090, you may understand collinearity so well, you can make your own total eclipse predictions. This was Thinkful. Thanks for watching.